Chemical kinetics. Area of chemistry concerned with the rates of reactions. Factors affecting reaction rates. Physical state of reactants, concentrations of reactants, temperature at which the reaction occurs, presence of a catalyst. Enzyme. Protein molecule that acts as a biological catalyst. Reaction rate. Change in the concentration of reactants or products per unit time. M per second. Units for reaction rate. Average rate of appearance of B. BFBI blank TFT. Average rate of disappearance of A. AFAI TFT. Instantaneous rate. Rate at a particular moment in the reaction. Initial rate. Rate at t equals 0. Rate law. When AABB to CCDD, then rate equals K A caret B caret. Rate constant. Constant K in rate law. Magnitude changes with temperature. Units of K. M caret S caret when rate is second order overall. Reaction orders. Exponents m and n in a rate law must be determined experimentally. Overall reaction order. Sum of the orders with respect to each reactant in the rate law. Units of rate constant. Depend on overall reaction order of the rate law equal to units of rate divided by units of concentration. Zero order. Changing concentration of reactant has no effect on rate. First order. Changing concentration of reactant produces proportional changes in the rate. Second order. Doubling concentration causes the reaction to increase by a factor of 2 squared equals 4. First order reaction. Reaction whose rate depends on the concentration of a single reactant raised to the first power. Differential rate law. Form of a rate law which expresses how rate depends on concentration. First order integrated rate law. Lane A T lane A 0 equals Kt when units of A are the same. First order reactions yield a straight line when graphed with natural logarithm. Second order reaction reaction whose rate depends on the reactant concentration raised to the second power or on the concentrations are two different reactants, each raised to the first power. Second-order integrated rate law. 1. A T equals KT1, a 0 when just one reactant and rate equals K A squared. First-order graph. K is slope. Second-order reactions yield a straight line when 1 A T is graphed. Second-order graph. K is slope. Half-life. T, time required for the concentration of a reactant to reach 1/2 of its initial value. (0.693 T, half-life of a first-order reaction. 1. Half-life of a second-order reaction. Increases. Rate of reaction blank with increasing temperature because of increase in rate constant K. Collision model accounts for reaction rates being affected by both concentration and temperature because molecules must collide to react. Orientation factor. Molecules must be oriented in a certain way during collisions in order for a reaction to occur. Activation energy. Minimum energy required to initiate a chemical reaction, E. Activated complex. Particular arrangement of atoms found at the top of the energy barrier to formation of products. Fraction. Blank of molecules that has an energy equal to or greater than D is F equals E caret, where R equals 8.314 J per mole K. Arrhenius equation. K equals A asterisk E caret. Frequency factor. A is constant as temp is varied, related to frequency of collision and the probability that the collisions are favorably oriented for reaction. Decreases. Reaction rate blank as E increases. ER. Slope of graph of lane equals E, lane A. Equation. Lane equals E, R asterisk. Reaction mechanism. Process by which a reaction occurs. Elementary reactions. Processes that occur in a single event or step. Molecularity. Number of molecules that participate as reactants in an elementary reaction. Unimolecular. single molecule is involved in reaction. Bimolecular. Elementary reactions involving the collision of two molecules. Intermolecular. Elementary reactions involving the simultaneous collision of three molecules. Multistep mechanism. Consists of a sequence of elementary reactions. Intermediate. Molecule in a multi-step mechanism that is formed by one elementary reaction and consumed by another. First order. Rate law of a unimolecular process, rate equals Ka. Second order. Rate law is blank in case of bimolecular elementary steps, rate equals Ka(b). Rate determining step. Slowest elementary step of a multi-step mechanism, limits overall rate of reaction, governs rate law. For overall reaction. Fast initial step. We can solve for the concentration of an intermediate by assuming that equilibrium is established in the fast step. Catalyst. Substance that changes the speed of a reaction without undergoing a permanent chemical change itself. In the process, generally by lowering the activation energy. Homogeneous catalyst. Catalyst that is present in the same phase as the reacting molecules. Heterogeneous catalyst. Catalyst that is present in a different phase from the reactant molecules, usually a solid. Adsorption. Binding of molecules to a surface, generally initial step of heterogeneous catalysis. Active site. Specific location on an enzyme from reaction is catalyzed. Substrates. Substances that undergo reaction at active site. Lock and key model. Substrate is pictured as fitting neatly into a special place on active enzyme. Enzyme inhibitors. Substances that binds to enzyme whether to block the active site or change its shape so that the enzyme can no longer work efficiently. Turnover number. Number of individual catalyzed reaction events occurring at a particular active site.